You can own the earth and still, all you'll own is earth until you can paint with all the colors of the wind. Pocahontas. um, Pocahontas was talking about, um, you can conquer all the land you want. You can conquer all the earth you'll want, but all it'll ever be is dirt until you can, play with nature. Until you can learn to be a citizen of nature. And she's talking about, painting with the colors of the wind. We're going to be talking about painting with the colors of humanity. We're going to be talking about using computers to tell screens what colors to display. And just like in Pocahontas, all you'll ever be doing is putting some dots on the screen. You're going to learn how to do all this powerful stuff because you're learning to put dots on the screen. But all you're ever going to be doing is just making dots in different colors until you learn to enjoy the beauty, until you learn to play with it. Until you learn to paint with not with dots and numbers in the computer, but with your soul. Okay, all right. So colors on the computer, and really just colors for all digital screens. I mean, this goes for your phone. This goes for your TV. This goes for pretty much all screens ever. Period. And this is actually going. We're going to talk about more than just TVs. We're going to talk about just colors in general, and humanity, and how different, how you perceive colors and how I perceive colors. And the best fucking part about this is I'm colorblind. So you're gonna be learning about colors from a fucking colorblind person. So congrats. Alright, so here's the deal. What even is colorblindness? Let's talk about how you and I perceive colors and what's the difference. Okay, so in your eyes. So your brain is the thing that sees colors, right? Your eyes don't see colors. Your brain is the thing that creates images. And what it does is it takes information that the eyes give it, and then creates the image from the information that your eyes have given the brain. So your eyes are basically these sort of sensors, these devices. They're kind of like a microphone. You can think of it like kind of like a microphone or a camera. I guess a camera's more accurate because it takes light. But I think a microphone is kind of a simpler idea, right? It's just you can think of a microphone, the fact that sound goes into it, and then it just sort of records the vibrations. That's what your eyes are doing with light, but on like a much more complicated level. Now with colors, your brain needs information from the eyes to figure out what color something is. Your brain is actually capable of seeing all sorts of colors, but it doesn't have the information to see those colors. So it only has the colors that we all see are based on the limited information from our eyes. Now, so how does that work on a little bit more specifically? So the light goes into your eyes, and it passes through these filters, and these filters are called cones. And these filters called cones, they try to separate out the colors into categories, into general categories. So there's three. So there's like a red category. So if the light comes in, it's like, oh, this is red. It'll go into the red category. The red cone will, I guess, will let the brain know that, oh, this is red. I guess that's how that works. And then there's other cones, green cones. Right? It's not like you just have one red cone. You have like a bunch of red cones, and you'll have like a bunch of green cones. And then the last cone type is yellow and blue. It's not yellow cones and blue cones. It's a yellow and blue cone. It's yellow and blue in it's one type of cone. So you have three types of cones. You have red cone, green cone, and then yellow and blue cone. So this whole idea, we're all raised that red, yellow, and blue are the primary colors. I mean, this is horseshit. I don't know where anybody gets this from. This is complete horseshit. Nothing works that way. Your eyes don't work that way, right? Your eyes do not have a fucking red cone, a yellow, and a blue cone. They have a red cone, a green cone, and then a yellow and blue cone. And the computers don't have fucking... the screens, your phones, these monitors, they're not creating those colors using red, yellow, and blue to do so. They're using red, green, and blue, just like your fucking eyes. So let's get into the nitty gritty. All right, now that we kind of have color blindness first. Sorry, color blindness. So what is color blindness? Color blindness basically just means that I don't have enough cones for my brain to figure out the correct colors. So it'll just give me the wrong colors. It'll just create the wrong colors because it doesn't have the right information. Or I guess I should say it creates less accurate colors, right? Because maybe you see the wrong colors sometimes. Maybe you could see more accurate colors if you had more cones. How about that? But no. So, and 1 in 20 guys is colorblind. So everybody knows somebody who's colorblind. And a lot of people are in denial. It's kind of funny. They're like, I can see colors. I'm not colorblind. I'm color challenged. Okay, so we get it now. So red, green, blue. This is basically how these screens create colors. They have these little lights in them. These little red lights, these little green lights, and these little blue lights. And they're adjusted such with different intensities or brightnesses. I don't know if that works. I'm assuming. And via that they create the colors that you see on the screen. And so all you're really doing is feeding three numbers to the computer when you're telling the computer what to do. You're feeding a value for the red little light, you're feeding a value for the green little light, and then a third value for the blue little light. Red, green, blue, RGB. I'm going to say it like a million times. And that's it. It's really that simple. It's just three numbers. And those numbers are from 0 to 255. You're like, well, that's pretty fucking random. What kind of dipshit picked those numbers? It has something to do. It just mirrors the computer architecture. Right, because computer memory is based on powers of 2 because there's geniuses, I guess. We're there. I don't know. It's just whatever. I don't want to have that discussion about float 2. It's fucking binary bullshit. So anyway, yeah. So the reason it's 250 is 0 to 255 is because 0 to 255 is a total of 256 numbers. And that is a representative of a power of 2. I don't know what that is, what that's called. I don't know what a number. It's not a multiple. Whatever a multiple is for exponents, that's what it is. And 0 meaning it's the light's completely off, and 255 means it's as bright as possible. So if you were to set all three lights, your red, your green, your blue, all to 0, you would have a black color. If you were to set all your lights, red, green, blue, all at 255, it would be a white color. If you were to set your red color to 255 and all the other ones, the green and blue ones, to 0, you would get what? What would you get? Oh, you guessed it. You get a red color. How do you get a brown? Well, brown is just actually red and green combined. Combine red and green, you get a brown. How do you get a yellow? You actually just take that brown and you make it a little lighter. How do you make it lighter? You turn up those numbers. So like maybe like a 200 red and a 200 green would be probably a yellow. I hope that's light enough to be yellow. I'm just throwing a number out there. And yeah, you just take these numbers and you combine them together to make different colors. And there's different tools online. You don't have to actually like do all this shit manually. You can just there's things online where you can just pick the color and then it'll tell you the number you have to use, and you can build your own. Imagine that. And so yeah, it's really that simple. It's just 3 numbers, 0 to 255, and they get sent to the computer, and that's how the computer determines the color. And so for each pixel, you'll determine the color for each pixel. So if you have like a 100 by 100 image, that's like fucking 10,000 pixels that all have to be sent these 3 numbers. Sorry, I had to take a hot chocolate coffee break. It's vital. So now we take these 3 numbers and it's not like an array. We don't send it to as like an array of 3 numbers. No, instead, the format, the official format for RGB values is going to be the hexadecimal format. It's hexadecimal. And it's a string. It'll basically be a string. It'll have a hashtag in front of it for all you cool kids, all you cool cats and kittens out there. What we old people think of as a pound sign. So, anyway, pound me too. It's a very funny hashtag. So anyway, we take this. So it's a string. Begins with a pound sign, a hashtag, and then it's followed by 6 digits, which will be 3 hexadecimal numbers placed side by side. Okay, so what? Okay, it's cool, dude. You lost me at hexadecimal. So now, whatever you said after hexadecimal, I didn't hear. We just went at it, just didn't process. Okay, so hexadecimal is okay. So you know what binary is, right? You have an idea that binary is basically like a number. Like you take a number like 1 or 2 or 3, and you just represent it with zeros and ones. And if you don't really have a hard understanding of what the fuck the difference is between a base 10 and binary, let's just go over that real quick. So a base 10 system is what we call what you and I are just familiar with as math. All right, like the way you and I were all taught, you, I, and everybody else was all taught math was you learn the 1 through 10, right? And you learn the number 0 and all that. And when you write all your numbers, when you write out 100, you don't like make like 100 little dots to represent the number 100. You just use these 3 digits. They're kind of like letters or symbols, right? You just use the digit or the symbol 1, and then you use a symbol 0, and then you use another 0, right? You use these 3 symbols to represent the quantity or the amount 100. Right? You don't use 100 symbols. You just use 3. And so those symbols, all the number of symbols that you have is going to be your base. So we have 10 symbols in total. We have the symbols 1 through 9, and then we have the symbol 0, which the total of 10 symbols. So we have a base 10 system. All binary is, right? And the thing is, we could have, it doesn't even matter. We could invent more symbols. We could eliminate symbols. It doesn't really matter how many symbols we have. And what binary is, it's just representing the same numbers, but they only have 2 symbols to represent all the numbers. So, just like when you get to the number 9 and you have to go to 10, you have to there's not a symbol for 10, right? You have to go, you have to use the symbol 1 and then use a 0 to show that you've got a whole quantity of 10. Well, all binary is, right, is 2 symbols, and all hexadecimal is 16 symbols. And that's what hexadecimal literally means. I mean, decimal is 10, right? We have the decimal system. Base 10 is a decimal system. And then the hexadecimal is 16. So 6 hexadecimal, 6 decimal times 16, blah, blah. And you don't have to know how to do this by hand. You're not going to be convert. You're not going to have to know the ins and outs of hexadecimals and shit like that. You're not going to have to be an expert on hexadecimals to work with them. You just have to kind of be comfortable with them, and you have to know that you can call a function that's going to change a decimal number, a number that you and I are familiar with, into one of these weird 16 symbol hexadecimal numbers. Okay, you don't have to know how to convert it. You just have to know that there's a function that you can call to do it, and you have to just know how to Google it, right? You have to know the terminology. You have to just Google, C# convert hexadecimal, or convert to hexadecimal. JavaScript convert to hexadecimal. Python convert. You know what I mean? Whatever it is, you have to know how to Google it. So you have to, in order to Google it, you have to know the terminology. That's why we're blabbing on about it. So that's what you'll do. You'll take your three numbers, 0 to 255, and you'll convert each one into a hexadecimal format by calling some sort of built-in function in whatever language or toolbox you're using. And if it's not built in or whatever, you'll just Google it. Somebody has had to do it. It's not a strange thing. Everybody has to do it. So you're not going to have to worry about doing it yourself by hand. All right, so that's it. That's all you do. You take these three numbers, you convert them into this weird format, and then you put a little hashtag in front of them, and it's a string, and that's a hexadecimal number. And obviously, when you're making strings like that, they all have to be the same length. So if for some reason you did choose to have like a 0 value to like represent black, or a dark color, maybe just red, so the green and blue are 0. You would need to pad it with a 0 on to the left of it. So instead of just being 0, it would need to be 0, 0, if that makes sense. You know, if you're going to send the value of a 5, it would need to be 0, 5. And that's it. That's how easy colors are. That's how pretty much all fucking colors work. I can't even see these fucking colors. So, yeah.